In recent weeks, the same question has been discussed more and more often within closed US military circles. Can humanoid robots become the next key battlefield technology? Formally, the Pentagon continues to state that autonomous combat systems remain at the stage of research and experimentation. But according to insiders from the defense industry, interest in Tesla Optimus robots within US military structures has sharply increased. The reason is simple. China has begun demonstrating large-scale programs for army robotization and AI integration into military exercises. Officially, Chinese videos are presented as demonstrations of dual-use technologies, robots for rescue teams, logistics, and soldier training. But analysts see this as preparation for a new format of hybrid armies where autonomous platforms enhance human fighters. Against this backdrop, according to sources, the Pentagon has begun considering Optimus not just as an industrial assistant, but as a potential platform for military research. Insiders claim that closed consultations are already taking place between Tesla representatives and US defense contractors. This is not about a direct order for combat robots. The wording is far more cautious. Development of AI for humanoid platforms, navigation training in complex environments, interaction with military units, and operation in conditions close to field missions. Formally, these are robots to support soldiers. But in the long term, such programs create the foundation for far more serious application scenarios. The Pentagon's key interest is not in a robot with a weapon, but in a platform with a human-like body capable of operating where wheeled or tracked vehicles are ineffective. A humanoid can climb stairs, open doors, carry equipment, and work in destroyed buildings, tunnels, and dense urban areas. Optimus, as conceived by Tesla, is designed as a universal worker, which makes its architecture well-suited for military support tasks. Reconnaissance in dangerous zones, equipment delivery, casualty evacuation, and operation in areas of chemical or radiation contamination. Particular interest is focused on Tesla's AI control loop. Optimus is trained on massive datasets of real-world perception, visual recognition, navigation, and object manipulation. In a military context, this is critical, as a robot must function in chaotic environments without clear markers, stable communication, or controlled conditions. According to sources, military researchers are considering adapting Optimus neural networks for tactical perception tasks, such as threat recognition, environmental analysis, and real-time coordination with humans. Why Tesla in particular? Because the company possesses what traditional defense contractors lack: scalable AI infrastructure and experience training autonomous systems in the real world. Autopilot technologies, computer vision, and distributed computing can be directly transferred into robotics. If Optimus becomes a mass industrial product, the military could use the same platform for research without developing a robot from scratch, lowering the barrier to entry in a new technological race. According to reports, Pentagon generals are especially concerned about how quickly China is scaling its robotization programs. The discussion is not about hundreds of prototypes, but tens of thousands of autonomous platforms undergoing training and testing in real scenarios. Even if these robots are not combat systems today, tomorrow they could form the basis of hybrid units where AI manages logistics, reconnaissance, and coordination. In this context, the US does not want to fall behind, which is why interest in projects like Optimus has intensified. It is important to emphasize that no one is officially speaking about creating an army of Tesla robots. Such an image would be too controversial for public opinion, but many technological shifts follow this pattern in their early stages. First research, then pilot programs, then gradual integration into real processes. The same happened with drones, which began as experiments and later became a key element of modern conflicts. If we look 10 to 15 years into the future, the picture may look radically different. Robots will cease to be merely assistants and factory workers. They will become part of security infrastructure, facility patrol, border protection, escorting military units, and operating in high-risk zones. In this scenario, Optimus could evolve from a worker robot into a universal platform on which dozens of specialized modifications are built, from rescue to military versions. The most troubling issue is ethics and control. When autonomous systems begin making decisions in dangerous situations, the question of responsibility arises. Who is accountable for an AI error? The developer, the operator, the commander, the state? International rules on autonomous combat systems still lag behind reality. Technology is advancing faster than any agreements. If the AI robotics race between the US and China accelerates, the world could find itself in a situation where autonomous platforms become a standard element of military systems without clear global restrictions. Ultimately, the Pentagon's interest in Optimus is less about a specific robot and more about the beginning of a new era, an era in which AI and humanoid platforms move beyond laboratory experiments and become part of the strategic balance of power. If these trends continue, future wars may be determined not only by the number of soldiers and tanks, but by the quality of algorithms, the level of system autonomy, and the speed at which machines learn in the real world. There is another critically important aspect that is rarely discussed publicly: the data and simulation infrastructure on which combat AI systems are trained. In modern autonomous platform development programs, up to 90% of training takes place not on testing grounds, but in virtual environments. For Optimus, this could mean digital twins of cities, industrial facilities, and training sites where AI lives through millions of scenarios in a matter of days. Insiders claim that US military research centers are interested in integrating such simulations with Tesla platforms, not to create robot soldiers, but to rehearse scenarios supporting units in extreme conditions. The next level is swarm coordination of humanoids with drones and ground vehicles. In future hybrid unit concepts, humanoid platforms do not operate alone. They become part of a network. Drones provide aerial overview, ground robots handle logistics, and humanoids work in complex spaces requiring human-like dexterity. Such integration requires a unified AI control loop that distributes tasks in real time. Here, Tesla's experience in managing large fleets of autonomous machines, autopilot, robotics, and energy systems, appears particularly attractive to military researchers. There is also the issue of cybersecurity in autonomous armies. Any network of robots is a potential target for hacking, signal spoofing, and attacks on decision-making algorithms. Therefore, alongside AI platform development, the Pentagon and defense contractors are investing in secure communication protocols, autonomous offline operating modes, and behavioral verification systems capable of detecting anomalous robot behavior. Insiders say that one reason for interest in Optimus is its architecture with local computing capabilities. The robot can continue operating even if it loses connection to a central control system. Another layer involves logistics and manufacturing. For autonomous platforms to become widespread, an industry capable of producing thousands of units per year and maintaining them through updates is required. Here, Tesla again holds a unique position. The company knows how to scale production of complex devices and update them over the air. In a military context, this would mean the ability to rapidly distribute algorithm updates across entire robot fleets, similar to how Tesla vehicles are updated today. The Pentagon's interest in platforms like Optimus is therefore not an isolated episode, but a symptom of a deeper shift. A shift toward an era in which machine intelligence becomes as strategic a resource as oil, energy, or rare earth metals.